So for merge sort, it's a recursive algorithm where essentially you start off with your unsorted array and you split it in half, and then for each half you split it again, and you basically keep splitting the array until they turn into individual elements, and then you start merging the elements together until your entire array is sorted. So if we look at this array here, it's unsorted, and then we split it in half. So for this half and this half. And then for each half, we split it again. So we look at this half here, we split it into this half and this half. And then for each half, we split it again. So for this half, we split it here and here. And we see that we can stop splitting because now they're just individual elements. And we do that for both sides of the array. I just didn't write this side out. So once you've split the array into individual elements, you can start merging them. So for these two elements, I can merge it into an array that will look something like this. And then for these two elements, we'll merge them as well. So and whenever you merge them, you merge them in a way such that the values are sorted, and I'll touch on that a little later. But so yeah, so it'll be 1 and 3 because you want the array to be sorted. And then you've merged these values, so you want to merge these arrays now. So if I do that, it'll be a 4-element array. And it'll be 1, 1, 3, and 50. Okay, and you keep on doing that for both sides until you end up merging all the elements back together, and then your array will be sorted. So I want to talk a little bit more about how the merging actually works. So essentially, if you have these two arrays that you want to merge together, first you need to create a new array that the values are going to go into, and then you start with 2 pointers, both at the front of each array, and you basically compare the values that the pointers are pointing to. So right now, both pointers are pointing to 1, so I'm just going to take the value in this array and put it here. And then once I've taken the value that this pointer is pointing to, I can move the pointer up. And then I'll compare the values again. Oops. And then, so I'll see, okay, now this pointer is pointing to 1, this one's pointing to 50. So I'm going to put 1 in the array since it's smaller than 50. And then I'll move this one up. And I compare, okay, 3 is less than 50, so I'll put 3 in the array. And then at this point, this pointer is already out of the array. So we just put whatever elements that are left from this array into the new array. So we just put 50 in. So then the array is sorted. So we can see from this that the merge sort algorithm is stable because we see that for these two ones, the fancy one started off at the left of this normal one, and then after it was sorted, the fancy one is still on the left side of this normal one. And we can see here as well. In the original unsorted array, the fancy one is in the left side of this one, and then as we sorted the array, the fancy one is still on the left side of this one. Unfortunately, merge sort is not in place because in order to merge the two arrays, we needed to use extra memory by creating a new array. Okay, so for the complexity of merge sort, we know that in the worst case, for merging, we're going to have to loop through every element in the array. So that'll be O of n. And we're going to have to do this merging algorithm for every layer in merge sort. And we know that since we continuously split the array in halves, we know that there's going to eventually be log n layers that we're going to have to merge. And therefore, the worst case complexity of merge sort is O of n log n, which is still pretty good. It's much better than the O of n squared of selection sort, but unfortunately merge sort does have to use extra memory.